Okay, now we'll look at some of the problems in 1604, starting with number 4. We just want to put this in polar coordinates. So it's a quarter of a circle between 1 and 3. So r, the radius, is between 1 and 3, and theta is in the first quadrant, so it has to be between pi over 2 and 0. So that's our region in polar coordinates. Number 8, I have 0 to pi over 2, 0 to 4 cosine theta, r dr d theta. So sketch the region whose area is given. So I need r to be between 4 cosine theta and 0, and theta to be between pi over 2 and 0. Well, 4 cosine theta is a circle, and if you start at 0, it's 4, and pi over 2 is 0, and theta is between 0 and pi over 2, so I get that half circle. Let me draw it better than that. And that's my region R. That's what this is. So it's just a half circle. Then it says evaluate the integral. Okay, so we integrate r, so that's r squared over 2. Evaluate that from 4 cosine theta to 0. And then we integrate that. And we have to use the half angle formula. That's 1/2, so that's going to be 4. 1 plus cosine 2 theta d theta. We integrate that, we get 4 theta plus sine 2 theta over 2 from 0 to pi over 2. And that's going to be 4 times pi over 2, and the rest is 0. So that's 2 pi. So that gives us the area of that region because our function is 1. So 2 pi is the area of this circle, and it's we could use a half circle. It's a half pi r squared. Our radius in this case is 2, and that gives us 2 pi. So that checks. We can use geometry to find the answer really quickly. Okay, in 10, you get we're going from lies to the left of the y-axis, and the radius is 1 and 2. So I have r is between 2 and 1 for my region, and theta is between pi over 2 and 3 pi over 2. So we integrate 1 to 2. We change x to r cosine theta. We change y to r sine theta. R dr d theta, and theta is from pi over 2 to 3 pi over 2. So this is x, this is y, and this is dA. Okay, so integrating that with respect to r, well, that just gives us r squared. The rest is constant, so that's going to be r cubed over 3 from 1 to 2. That's going to be 8/3 minus 1/3 cosine theta plus sine theta, which is 7/3. Then I integrate that with respect to theta. So that's sine theta minus cosine theta. Okay, so that gives me a minus 2. That gives me negative 14/3 for my final answer. Okay, 18. I have r equal 4 plus 3 cosine theta. The picture of that looks like at cosine 0, at 0, I get 7. At pi over 2, I get 4. At pi, I get 1. So I get a limison. And I want inside there. So r varies from 4 plus 3 cosine theta to 0. And theta is 0 to 2 pi. So we're going to integrate r from 0 to 4 plus 3 cosine. And theta goes from 0 to 2 pi. And don't forget this extra r. Oh, I'm not integrating over the surface. I'm integrating the area. Again, this is two-dimensional, so we let f of x be 1. So f of r theta is 1. Because in number 18, we just want the area of the region. I'm not going to evaluate that because that's pretty easy to do. I'll let you do that, and I'll just set it up for you. Okay. Try 20. And 20, I want it inside and outside this. So I want it outside, r equal 2, that's radius 2, and inside, this is for this circle, so I want it from here to here. We have to find the points of intersection. So set them equal. We get pi over 6 and 5 pi over 6. Okay, and I want, again, the area of that, so I'm just going to integrate r dr d theta. And for r, I want to go between 2 and 4 sine theta. And my theta, I want to go between pi over 6 and 5 pi over 6. And again, I'm just going to set that up and let you integrate. That's not a hard integral. Okay, let's look at 22. I want it inside and outside. So I'm going to draw a picture of this one. This is a volume. So I'm going to integrate the area of the cross section. In the xy plane, z is 0. I don't know if I need that or not. And if I draw this, what I have is a sphere. And then I have a cylinder. Okay, this is 4 and 4. Then I have a cylinder here, and I'm going to cut out. And that's just in the first octant, the picture. Um, and I want this area around, or the volume around that. And I'm only going to do the top half and then multiply by 2. So on the top half, z is bigger than or equal to 0. I have z squared is 16 minus x squared minus y squared. I have z equals a positive square root because, again, I'm just doing the top half. Now remember, x squared plus y squared equals r squared, so I can change this to the square root of 16 minus r squared. Okay, then if I look at the picture, let me look at the base. This was the x-axis, this is the y-axis. And the region was this, and this radius was 2, and this radius was 4. So to start out with, I'm going to integrate from 2 to 4. With respect to r, and then theta is going to go all the way around because I want the whole thing. So theta is going to go from 0 to 2 pi. So that's the top half. If I multiply by 2, I get the top above z greater than 0 and the bottom. Okay, and again, I'll let you integrate that. That's, oh, I need an r, extra r. It's not too hard to integrate. You have to use substitution there. You always need that r because this right here is dA. Okay, again, I'm just going to set these up. 26, let me draw a picture. Let me start a new page. I have z equal 3x squared plus 3y squared, and I have z equal 4 minus x squared minus y squared. So I have two paraboloids. The first one, I have 3x squared and 3y squared, so that's going to look like this in the back. Those are the level surfaces. And then in red, I'll do this one. That's an upside down parabola. So starting at 4, it's going to go upside down. So I have, it's going to intersect there. I have this, the intersection of those. It's going to look kind of like an egg. Now, right where they intersect, I'm going to get 4x squared plus 4y squared equal 4. X squared plus y squared equal 1. Okay, so that's this right here where they intersect. And all the other ones are smaller. So I know that's true. When I integrate this, or I know r is less than 1, less than 0, and I'm going to change this to polar coordinates. I'm going to take this upside down region, let me call it region 1, or paraboloid 1, let me use a P. And the blue one, or the red one is, well, P1 is upside down, and let's see, the black one is P2. So I'm going to do P1 minus P2 to get that egg shape. Okay, so set this up totally. Now R is between 0 and 1. So I have 4 minus x squared minus y squared, and that could be 4 minus x squared plus y squared. So that's 4 minus r squared. And this one is 3r squared. So I have 4 minus r squared minus 3r squared dr. And then theta goes all the way around 0 to 2 pi. So that's going to give me the volume of that region. And then I keep forgetting this, another r. So let me rewrite this 0 to 2 pi, 0 to 1, r times 4 minus 4r squared dr d theta. And again, that's easy to integrate. So again, I took the paraboloid 1, which is the upside down red one, and subtracted paraboloid 2 from it, and I get the egg-shaped region. Okay, one more. This is 30. I want to change this to polar coordinates. Remember, r squared is x squared plus y squared, so right away I can see that's r squared to the 3 halves. Then this changes to r dr d theta, so I have dA, that's dA. And if I look at this picture here, I have x equals the square root of a squared minus y squared, which is a circle, and it goes from 0, x goes from 0 to that circle, so I get the top and the bottom because y can be positive and negative because y is squared here. So this is the region from minus a to a, because this says that x is positive. I know that also this is x squared plus y squared equal a squared, which is a whole circle, but since I'm taking only the positive, where x is positive, I get it in quadrant 1 and quadrant 4. So r, the radius of that circle, this changes to r equal a, so I'm going to go from 0 to a, but I'm going to go, since I'm doing quadrant 1, quadrant 4, it's negative pi over 2 to pi over 2. And that's going to give me the circle in quadrant 1 and quadrant 4. And there I changed it to polar coordinates. Okay, I hope this helps you with your homework.